My name is Shane. I am a former Java developer and architect, is how I started my career back in the days at Red Hat. And then I kind of pivoted into more of the intersection between product and marketing for a number of database companies, particularly in the NoSQL space and distributed database space, which naturally evolved into AI, which is why I'm here today. I'm excited to share with you a little bit more information on today's topic of how do we put together both unstructured and structured together in our RAG pipelines. Little note in the agenda. I'm going to start with a little bit of context. So for those of you that are knee deep in enterprise AI, just bear with me. I just have a few slides to talk about kind of some high level trends that I'm seeing, kind of the core tenets of AI data development, right, and how that relates to enterprise AI. And then we'll get into kind of this notion of unstructured and structured data, right? What do those pipelines look like? Agentic RAG, which is something that I think is still a little bit early in terms of adoption, but I think is really, really powerful. The more I talk with data scientists, kind of line of business, executives, what a lot of enterprises have in common is that, in a sense, SMBs have become a bottleneck. These are the folks that have the most, internal business or industry knowledge, right? Expertise. But a lot of what they do requires manual effort. And because these folks are far and few in between, and very skilled, you kind of run out of bandwidth, right? There's only so many documents they can review, so much information they can scour for and put together. They require training. They often have years or even decades of experience. So if you're trying to increase productivity, you're trying to scale your business, one of the places people are looking at now is AI, right? And I see kind of two examples taking place here. One of them I would say is AI copilots, right? This isn't too different from, say, GitHub Copilot and the effect it has on developers. This is the same thing in terms of SMEs. So I made a little example here. But let's just pretend we have an SME, maybe at a call center. That person can handle 5 requests an hour, right? I guess that seems low for an example, but let's roll with it. If they had a co-pilot available to them, maybe they can handle 20 requests an hour, right? It's going to help them save time, be more efficient. The other path is an AI assistant, which kind of becomes your frontline SME, right? So the ability to offload requests that typically would have gone to a person, the AI assistant can now handle directly. So in my little example here, if we were to improve, SME productivity from 5 requests an hour to 20, and then we introduce an AI assistant that's able to offload, an additional 10 requests an hour, we can go from handling 5 to handling 30. So it's kind of a little bit contrived and made up here, but that is, in a sense, how I'm seeing it when I talk to folks at conferences and elsewhere. Pilots and assistants tend to be kind of the first step, to using generative AI to kind of help improve productivity. The challenge that we'll start to get into here is we obviously want, employees or customers now interacting with these co-pilots and assistants. But how do we transfer all of that domain knowledge, right? All that information, whether it's in PDFs or it's in relational databases, how can we make that, a part of that AI Copilot assistant so that it can provide us high quality, accurate responses? And that's where AI data development comes in, right? So we kind of come back to this. We know that, our AI Copilot is going to be more effective, right? The answers are going to be more accurate, more complete, of higher quality, the more we can transfer that knowledge into it. But if you think about it, what's really behind those AI assistants and co-pilots are one or more AI or ML models, right? Most often, the examples here, classification and information extraction in terms of predictive models. And then you have retrieval, generation, and evaluation in terms of generative models, right? These are kind of the backbone of your AI assistant or co-pilot. So the question is, how can we transfer this knowledge into these models? And so one way to look at it, I'll focus on the Gen AI component here, is each of these approaches has core components, models or features, which can be improved with training. And to be honest, the most common examples in the middle there, right? For retrieval, it's prompt chunk pairs, right? You're trying to improve the embedding model so it returns more accurate context for the LLM. In terms of actually fine tuning and aligning the LLM, typically labeled prompt response pairs, right? You have, say, questions and answers, and we're trying to determine which ones are good, which ones are bad. Maybe they're scored from 1 to 5. And then finally, one that tends to not receive as much attention as we think it should is evaluation, right? At the end of the day, whether you've stood up an out of the box RAG pipeline, or you've started that process of fine tuning the embedding model and maybe even the LLM too, you now have to evaluate the results. How well is it performing? Not in a academic sense, but in a enterprise sense. Do these responses meet our corporate policies, ethical standards, industry or government regulations? Are they the right tone that mirrors how our customer service reps, for example, would answer the questions? So really important to get that right. But all three of these really depend on curated and labeled training data, right? So you might start with a very large set of training data. We're going to label that training data through a handful of methods, which I'll touch on here. And then from that, we'll curate a smaller set of higher quality training data, which we can use in all three of these stages. For Snorkel Flow, if you're not familiar with it, I don't have the time to go into the details with today's particular webinar, but I think this sums it up nicely. The core of it is the concept of labeling functions. And the idea is that instead of having an SME go through, a data set of, say, 5,000 prompt response pairs, right? It's going to take a team of SMEs months, right? Maybe more than a year, depending on how big that data set is. What we want to do is collaborate with this SMEs and find out what is the logic they use to determine whether a response from an LLM is good or bad, right? Once we understand that logic, we can encapsulate it in these labeling functions. And now, instead of labeling, items in your data set one at a time, we will use that logic encapsulated in those labeling functions to label all of your training data at once. And that's where we get the really big boost in time savings. What would have taken months now takes hours, maybe days, depending on how large your data set is. Not only that, you tend to end up with higher quality training data because we're able to remove some of the subjectivity and bias by using these labeling functions. And so if we kind of circle back around again to the original context we set up, we're trying to build AI assistants and copilots. That's really what Snorkel Flow exists for, right? Through collaboration with SMEs, programmatic data development, which is how we're able to accurately label, thousands, tens of thousands, hundreds of thousands of data points, and then evaluating, the results, kind of doing an error analysis, and we start that loop again, right? It's a very iterative loop. At the end of the day, I'd say it's exceedingly rare that you label your data once and you now have training data that yields a production quality model. In practice, it's an iterative cycle, right? We capture that domain knowledge from SMEs. We use that to create labeling functions. We curate, kind of label our training data. Then we analyze the results. We look for errors. We find them. We work with the SMEs to address them and to resolve them, run those labeling functions again. And this process kind of continues at a loop until we've reached a point where our model meets your accuracy requirements, whether it's 90%, 95%, 99%. We keep on improving until we get there. And in terms of what we're seeing in the real world, we kind of have three examples of Snorkel customers in these three particular segments. And you can kind of see for yourself how big of an improvement it was. To be fair, the improvement depends on your use case, right? If you're working on something that is fairly simplistic and doesn't require a lot of domain expertise, then something out of the box might already be in the 70, 80, 90% accuracy range. And then optimization might bring you an additional 5 or 10%. But if you're working on something that's very specialized, right, very unique to your business, very important or critical, you would see what's on the left there, right? Your out of the box model is only 25% accurate because it just doesn't have the domain knowledge and information, related to your business. After incorporating that, now we're at 95% accuracy and we have something we can put in production and that the business can rely on. That being said, I want to get into what I thought was really kind of a fascinating question is when I do look at RAG pipelines in particular, I find that you're either on the side of doing unstructured data, PDFs and documents and presentations, or you're on the text to SQL side, right? And you're providing a very easy way for anyone in your business to use natural language to interact with a database. But I think there's even more value in both. And my simple example here, which you may have encountered, you have health insurance and you still receive a bill, right? And I'm that person. My first instinct is, why am I receiving a bill, even though I have health insurance? If we were, simply querying a database and structured data, we might get a list of line items back, right? So that the purchase and those bills, I'm sure they're put into a database, but I don't necessarily understand why I've been charged. I understand the services that I've had, but I don't understand why, given that I'm paying for health insurance, am I receiving these particular charges? On the other hand, if it was simply unstructured data, I might get a better understanding of what's in my plan and the coverage and kind of the rules, but I don't understand how those are related to my particular charges. But in a perfect world, if we had access to both, that structured and structured data, now we could have very good answers that correlate those together, right? You had a copay for visiting this particular doctor. You had this particular, diagnostic, which you had to pay co-insurance for, right? We can kind of make up these, but I'm getting a better understanding of why I've been charged. So as I said, we're typically kind of in this notion of one or the other, right? So if the document based, which you'd see a lot, is you have a prompt, it goes all the way to a retriever. It's going to kind of use an embedding of that prompt to find relevant information in your vector database, pass that along to the LLM to generate a response. On the other side, when I look at kind of very, early text to SQL solutions, we have a prompt, and then it kind of goes to the retriever. But what it's really doing is asking the underlying LLM, "Could you please generate a SQL query from this prompt?" Right? And then we'll run that SQL query against the database and return the results. So more often than not, in my experience, I've seen kind of implementations ending up on one side of the other. And that brings us to agentic RAG, which I think is really fascinating and something that I hope we'll be talking a lot more of in the future here. I'm just going to run through a few examples. There's actually many patterns, so please don't think of this as an exhausted list. But one interesting one is with routing. And this is actually something that Snorkel has been working on with some of our partners through the use of specialized models, where you might have two different RAG pipelines that are very specialized for a specific task. Maybe one pipeline is to help customers who are asking about their plans, right, and their coverage. You might have a separate pipeline that's specialized for dealing with billing questions. But if you think about the example I just went through, uh, maybe I didn't ask for the why part. I just said, hey, what are the, what services, resulted in charges that were sent to me. That router can kind of use an LLM and say, okay, based on this prompt, which one of these RAG pipelines is best suited to answering it? So it might route it to a billing one, or if I just wanted to know, is a certain service covered, it might route it to the plan one. And then it receives that response, and of course, it passes it along. The other option, which is probably a little bit closer to my example a little bit earlier, is synthesis, where we might choose to forward that prompt to both pipelines. So please get my plan information, please get my billing information, and then kind of synthesize both of those results and give me a summary as part of my response to help me better understand things. The other option is involving more than just a database, whether it's a vector database or a relational database, but potentially even other tools. So we might have a prompt that kind of goes to retriever, so it looks a little bit like a standard RAG pipeline, but then that context that's received goes to an additional agent, let's say a tool selector, that might check with an LM and say, is there additional information, additional tools that I should use to augment, this context. And so the question I had previously, it might say, yes, we've retrieved, the charges for this particular customer. We now need to retrieve the plan information as well. So we're kind of augmenting that context. Those tools could be anything, right? It could go fetch information from Salesforce, fetch information from a knowledge base, any other kind of APIs that are available to you, kind of combine that context and then pass it on to an LLM for generation. And then finally, the notion that agents can essentially have multiple agents available to them. So you think about it from an orchestration perspective, maybe we are creating kind of dynamic workflows, right? So we kind of use an LLM to help us kind of build, a workflow, right? A multitask operation, which each step in that workflow may ultimately be another agent, right? And that agent may itself have a workflow or perform a set of tasks. So it can kind of become very sophisticated, right? And specialized for the particular, problem that you're trying to solve. So that was a little bit about kind of our perspective on enterprise AI data development, RAG, and now agentic RAG.